Machine learning is often thought of as too complex, requiring programming in Python or R and an elaborate toolset. However, this is not necessarily the case. In this video, using just Google Sheets with the TableTorch add-on, we'll prepare a dataset and feed a model estimating the likelihood of a bank client to respond positively to a direct marketing phone call. Such a model can help to reduce the number of phone calls by up to 2/3, providing tangible business value in the form of savings on the calls, lower negative impact on customer satisfaction due to unsolicited calls, faster campaigns, and more time for other marketing activities. Let's begin! There is a link to the dataset sample in the video's description. It is real-world data collected by Moro et al. 2014. Each row represents a phone call attempt. The most important column for us is Y. A yes value means that the phone call was successful in persuading the customer to sign up for a term deposit. Our task is to build a model estimating this column, so as to filter the list of prospective clients and reach out only to the customers who are likely to respond positively. It would have been great if we could just apply the logistic regression to the dataset right away. However, as is often the case with raw data, some preparation is required. The regression can only process numeric data, whereas many of these columns contain categorical text data instead. Fortunately, with some help from the TableTorch add-on for Google Sheets, as well as a few formulas, we will be done with the preparation in a moment. We'll start with the conversion of yes-no values of the Y column to a numeric binary column with ones and zeros instead. Let's begin with starting TableTorch by clicking on its icon on the right side panel of Google Sheets. See the video's description for a link to Google Workspace Marketplace where you can install the TableTorch add-on to your Google Sheets account. Select the Y column range and click the Text Categories Encoding button. Check only the Yes phrase on the next menu, and then click the Binary Columns button. The newly inserted column contains ones and zeros in place of yes and no of the original column. Let's name it the observed result. We can apply the text categories encoding to a few more columns. For marital, select the married and divorced phrases. It is unnecessary and sometimes even harmful to add binary columns for every possible category, because they would have strong negative correlation that might confuse the regression. For contact, select only the cellular phrase. For housing, just the yes option will suffice. For default, let's catch only the no phrase. For loan, choose yes and unknown. For P outcome, let's look for both the failure and success. Once all the processing is done, we can give some of the new columns more appropriate names, hide the original columns, and see the result. It looks great! We have almost completed the numeric data extraction from the categorical text columns. If we look at the job, education, month, and day of week columns, we'll see that they contain many more categories than the previous ones. We could use binary columns extraction again, but it would produce thousands of extra columns and complicate further analysis. Let's use the target average encoding technique instead. The idea is to capture how frequently, on average, rows that feature a particular job or education category also feature a positive observed result. Let's begin with the job column. Create a job average column right next to it and enter a formula calling the AVERAGEIF function there. The first argument points to the whole range of the job column, the second to the job value of a particular row, and the third is the range of the observed result column. Note that the first and the third arguments need to contain exactly the same number of rows. Let's format the new column as percentage and apply a conditional background to make it visually clear. These values represent respective shares of the rows belonging to a particular job category that had a positive outcome of the marketing campaign. Now we can do the same for the education column. Insert an education average result column right next to it and enter a formula using the AVERAGEIF function there. Let's apply the format and the conditional background rule for this new column as well. Same goes for the month column and its new numeric month average result counterpart, and the day of week column that has been converted to the day average result column. There are significant differences between the various categories that are likely to provide the necessary numeric signal for the regression. At this stage, a good idea would be to look into a correlation matrix of the dataset to verify that all the columns provide unique uncorrelated input to the regression. Link to the video on using TableTorch to compute a correlation matrix should appear on the upper right corner. Here we can see that it doesn't make sense to include the employment variation rate column as a feature for a regression, because it is correlated with several other columns too strongly. Good, the preparations are over. Let's get back to what we wanted to do in the first place. The idea was to train a model on the collected dataset so as to use it on the new data, presumably representing a bank's clients that have not been contacted yet. The model will then filter the clients by the chance of a positive response. In machine learning, this task is called binary classification. We want to assign one of two classes to each record, either likely to subscribe or likely to reject. One of the most frequently used methods to feed such a model is logistic regression. As usual, let's begin by starting TableTorch. Click on its icon on the right side panel of Google Sheets. Video's description has a link to Google Workspace Marketplace where you can install the TableTorch add-on to your Google Sheets account. Select the whole range of the dataset and click the Logistic Regression button. It is important to carefully verify the list of features before doing a regression. In this example, we'll need to deselect two columns. We cannot use the duration column because its value represents the phone call duration that, let's face it, can only be known once a phone call is made, whereas we want to estimate the chances of succeeding before making a phone call. In other words, a model trained with a duration column won't work on the new data, that is, on the rows representing the clients who have not been contacted yet. We will also exclude the employment variation rate column due to the rather high correlations with other columns that we have discovered earlier. As you can see, there are many settings available in the TableTorch implementation of a logistic regression. Follow a link in the description to the full documentation if you'd like to learn more about them. For now, let's just edit the sampling options a bit to follow the best practices of machine learning. Select 5-fold cross-validation in the sample splitting menu and enable the sample with replacement option. These settings should help to produce a more reliable and precise model. Click the Fit Model button. The Learning Summary panel will appear shortly. The summary demonstrates the most commonly used metrics to gauge the quality of a binary classification model. Let's briefly discuss what these metrics represent and what these particular values mean. Accuracy is the percentage of the rows with an estimation that is equal to the label. 80% means that this model is 30 percentage points better than simply flipping a coin. Precision for a class is the share of rows for which the model assigned that class correctly. We see a precision for class 0 at an impressive 95%. This means that when the model assigns class 0, which is the won't-subscribe class, to a row, it is quite likely to be correct. At the same time, precision for class 1 of 30% shows that the model somewhat struggles with that class and often assigns it erroneously. However, this should not deter us from applying such a model in business, because it can still help to significantly reduce the amount of unnecessary phone calling, as we'll discuss in a few moments. Recall for a class is the percentage of the rows known to belong to that class, for which a model also assigned the same class. The recall for class 1 that we see in the learning summary is at 65%. This means that at threshold of 0.5, the model successfully classified 65% of the clients who would agree to open a term deposit in an actual call. AUC-ROC, that is the area under the receiver operating characteristic curve, is an often used metric to gauge the probability of the model's estimation being correct. TableTorch computes pairs of true positive and false positive rates at various threshold levels to virtually draw this curve and calculate the area underneath. The Learning Summary panel also shows the default threshold level of 50%. It is always the same, but it is important to understand that the precision and recall change with the threshold, and the metrics seen on the summary panel are correct only at the default threshold level. Let's take a brief detour and look at this hypothetical binary classifier. If we plot the model's estimates vertically, put the observed class 1 on the left and the observed class 0 on the right, we'll see a picture like this. True positives, that is, the rows where the model's estimation is positive and correct, are inside the top left quarter. False positives, where the model made a mistake and assigned class 1 incorrectly, are on the top right quarter. True negatives are on the bottom right, and the false negatives are on the bottom left. If we would like to improve the recall and reduce the number of false negatives, we would lower the threshold like that. The trade-off here is that the greater recall usually comes with lower precision. As you can see, there are many more false positives now. Likewise, to increase the precision and reduce the number of false positives, we would need to move the threshold up. Unfortunately, this comes at the expense of recall, or the amount of false negatives. In theory, it is possible to collect all the features in the world, program the best machine learning algorithm, and create an ideal model, with the precision and recall being both at 100%. In practice, it is of paramount importance for a business to clearly state the intended priority for the model being built. For example, getting back to our marketing campaign task. Let's say that the business is prepared to lose no more than 25% of the hypothetical future subscriptions. This means that we need to build a binary classifier with a recall of at least 75%. Let's set a summary sheet and see. The highest threshold that still qualifies is at 27%. We can also imagine another priority. For example, a business that has a budget for just 1,000 more phone calls. In such a case, it would make sense to sort the range by the model's output in a descending order and take the first 1000 rows. The threshold will then be the model's estimate of the last taken row, and one could look up the appropriate precision and recall metrics for that threshold in the model's summary sheet. Let's build a classifier with a 27% threshold. Click the Insert Prediction Column button on the Learning Summary panel. A column will be inserted right after the range the model was trained on. The column's formula does a few things. It applies standard scaling to the input features, then multiplies variables by their respective coefficients and processes the result with a logistic function to output the final estimate between 0 and 1 that roughly represents chances of a row to be of class 1. Let's add a binary classifier column, make a call, with the following formula. That's it! We've just built a binary classifier. Having the model and a binary classifier ready to find the clients most likely to react positively to the campaign, let's evaluate a few metrics to understand how this model can help with the campaign's continuation. The first is the observed number of calls, that is, how many calls were actually made so far. The second is the observed positive results, that is, how many calls resulted in a subscription. The third is the filtered number of calls, meaning how many calls would have been made if the list of prospective customers were filtered by the classifier. And finally, the fourth metric, filtered positive results. How many positive results would be there if the model were used? Now we can estimate the model's possible effect in percentages. The filtered number of calls is around 1/3 of the observed, while the number of subscriptions is still at 3/4 of the original. This could result in various favorable business outcomes, such as savings on the calls, lower negative impact on customer satisfaction due to unsolicited calls, and a faster campaign overall. Freeing up the resources can also help a company to attend to other marketing efforts. Thank you for watching. Click the like button and subscribe to GawiSoft's YouTube channel to watch more videos about simple tools for machine learning. Try using the TableTorch add-on for your analysis needs today. The link to its installation page, as well as its documentation, is in the video's description.